Hey everyone, so now that we've done our exponential derivatives, we're going to dive into log derivatives. Let's use a little bit less ridiculous of a color here. How about blue? Students are going to be able to find derivatives of log functions with a base e and any base. Let's take a look. So chain rule, logarithms, exponential functions, and log rules are things that are going to come into play here. First, we're going to take the simplest derivative we can with logs, which is the derivative of natural log, and there's going to be no limits, thank goodness. Derivative of natural log x. So we're going to do this using implicit differentiation. So we have y equals natural log x, and I want y prime of x. So we're going to do this kind of like we did with the inverse trig functions. So what I'm going to do is I'm going to get rid of this. So I'm going to rewrite it as ln x equals y. Remember, there's a hiding e right here, so I'm going to bring that over. I'm going to bump up the y. So I'm just going to write it in exponential form. So I have x equals e to the y power. And now I'm going to take the derivative of both sides, because I know how to do e to the y. So derivative of x is just 1. Derivative of e to the y is e to the y, leave it alone, and then multiply by y prime. I want y prime, so y prime is 1 over e to the y, but what's e to the y? It's x. That is so cool. Y prime is 1 over x. So the derivative of natural log, 1 over x. So if you think about that, natural log looks like this. Right? 1 over x looks like this. This makes sense to me, because originally we have very, very positive slopes. We have very, very positive slopes to start out with, so we start up really high. And then as the slopes mellow out, they're coming down here. Still positive values, right? But they're mellowing out, getting closer and closer to 0, because it doesn't approach a horizontal asymptote, but they just flatten out pretty quickly. It gets closer and closer to 0. So it makes sense to me that the derivative of natural log is 1 over x. So let's do some examples. Derivative of natural log of x squared. So I'm going to leave the x squared alone, 1 over x squared. Then multiply by the derivative of the baby function, which is 2x. Write that a little prettier. 1x cancels, so I have 2 over x. Cool. All right, next up we got natural log of sine x. We're going to find f prime of pi over 4. So let's do the derivative first, f prime of x. So it'll be 1 over sine x divided by the derivative of the baby, or multiplied by the derivative of the baby function, which is cosine x. So that's cosine x over sine x. Right, could think about that as cotangent x. I'm actually going to leave it. So pi over 4, cosine of pi over 4 over sine of pi over 4. So we're evaluating this x over pi over 4. So cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. It's 1. Look at that messy function. Derivative at pi over 4, just 1. Easy. All right, next up, we got y equals natural log root x. We're going to find the equation of the tangent line at x equals e. So let's do our point first. Point is going to be e, and then natural log of root e. Well, let's think about that. Natural log is asking, what power do I have to take e to get root e? I think that's 1/2, right? So that's just e 1/2. Nice. Now let's find the derivative. So y prime, so this is our slope. So y prime is going to be 1 over root x times 1 over 2 root x. Hopefully you've seen that root x derivative enough by now. You can just get right to 1 over 2 root x. That is 1 over 2x. So our slope is 1 over 2e. Equation y minus 1/2 is equal to 1 over 2e times x minus e. That's it. Nice. All right, this is a fun problem. I haven't done it in a while, so we'll see how it goes. This is similar to the one we had on that quiz review where it was like the one that went through a certain point on the y-axis, but this one through the origin, hopefully not going to be too bad. So let's draw a picture of this. Here's natural log. So there's a line that goes through the origin that is tangent to natural log. Not a lot of options, right? Because if it's going to go to the function, I guess it has to be up here somewhere, huh? So it looks like there's only one point, because any other point down here, it's going to go through the graph. So that's, I think, the only point where this happens, where it passes through the origin and is tangent to natural log. So we're going to do just like we did on that quiz review sheet. The coordinates here are, let's call it a, ln of a, right, because it's on the natural log function. Coordinates here is 0, 0. So we can find the slope two ways. So slope, the first way is like the traditional way that we find slope, right? Change in y over change in x. That's ln a minus 0 over a minus 0, which is ln a over a. So then the slope number 2 we find is derivative. Well, the derivative of natural log is 1 over x, and we're going to evaluate it at x equals a, because the slope of this line should be equal to the slope of the tangent at that point. So that's 1 over a. Then we just set them equal to each other. So we got ln of a over a is equal to 1 over a. Okay, well, I think the easiest thing to do now is multiply both sides by a. They cancel on both sides, so I have ln of a is equal to 1. Now we bump this up, so bring the e over. A is equal to e. Interesting. So the x-coordinate where this happens is right at e. That's kind of cool. What do they ask for? They ask for the slope. Which one's easier? Probably this one over here. Looks like the slope is 1 over e. That's our slope. So at the point x equals e, the slope is 1 over e, and it goes through the origin. That's kind of cool. All right, so now, of course, you're going to ask me again, what if the base is an e, Mr. Fransky? Because natural log is all we've done, right? The derivative of natural log of x is 1 over x. But now, what if we have different things, like log base a? So what if a is something other than e? We're going to use our change of base formula to be able to figure this out. So as we've said before, change of base, you put the base in the basement, right? And then you put the argument of the log up on the top, and you can choose any b that you want. There's no b on the left side at all. We can choose any b we want. What do you think we're going to choose? We're going to choose e, right? Because we know something about natural log. So I'm going to rewrite this as the derivative of the natural log of x divided by the natural log of a. Now, just like we were doing the derivative of a to the x power, natural log of a is a constant, right? So like, for example, if I was doing the derivative of log base 5 of x, at this point, I'm doing the derivative of log of x, natural log of x, ln x, divided by ln of 5. So again, ln of 5, that's just a number. That is a constant. So I can pull that 1 over ln a all the way out. So we'll do this in a couple steps just to make sure it's clear. So we have 1 over ln a times ln of x. So I just set this ln x next door. 1 over ln a, though, that's a constant, so I'm going to pull it out. So it's 1 over ln a times the derivative of ln of x. Well, derivative of ln of x, we know. It's 1 over x. So this is 1 over ln of a times 1 over x. Usually the way you see it written is 1 over x times ln of a, because then there's no confusion about whether the x is part of the natural log. And that's the derivative. So derivative of log base a of x is 1 over x ln a. This kind of makes sense to me because we have two now that have this natural log involved. Remember the derivative of a to the x was a to the x times ln a? If you think about this in terms of e, so if you're doing natural log, if this a here is e, or if this a here is e, natural log of e is 1, right? So this works out that it's e to the x and then just times 1. This would be 1 over x times 1 if you use e for the base. So you only really have to worry about the natural log if it's a base that is other than e. Nice. Okay, so let's try some examples. So first one, derivative of log base 6x cubed. So we're going to do our derivative straight up. So we have 1 over, leave the x cubed alone, times natural log of our base, which is 6. Then we multiply by the derivative of the baby function, which is 3x squared. We do some canceling out here. X squared over x cubed is 1 over x. That's 3 over x ln 6. Like this is just fine, but if this was a multiple choice, they'd probably present it like that. Next up, they want the derivative of f of x equals log of x sine x. Now, you guys might jump straight to product rule on this, right? You could do this as 1 over x sine x times ln of, what's hiding here? Log, this is a common log, there's a 10 hiding there, right? So this would be ln of 10, and then multiplied by the product rule of this thing inside. But I would urge you to use your brains, think a little smarter. We can do this better. Think about the log rule. This is a product in here. Log of a product turns into a sum of logs. So that's log of x plus log of sine x. Now, if you do this and distribute, you'll end up with the same thing, but I think this is way easier. So derivative of log x is 1 over x ln 10 plus 1 over sine x ln 10 times cosine x. Cosine over sine here, you could do a cotangent thing if you wanted to. I'm just going to leave it like that. Nice. All right. So in summary, derivative of natural log is 1 over x. Derivative of log base a of x, 1 over x ln a. Remember, that is a constant. And that's all there really was to this video. So good luck on the homework problems, and I'll see you in the next one.